Hey, our friend the mole. Anybody remember what a mole was? The number of atoms in 12 grams of carbon-12. You gave me the AMU, which is the individual atom versus the whole groups of atoms. Okay? So it's the number of carbon atoms in exactly 12 grams of carbon-12. That was our definition a long time ago. But what we get out of this is what the number is. Which on the final exam I saw that's one of the places people struggled was they didn't have Avogadro's number down. Right? 6.022 times 10 to the 23rd. It was just a very large dozen. Last time we did this, we used it to count atoms. Now we're going to be able to use it to count molecules and formula units. Because those are pieces too. So instead of counting the individual atoms, we're going to count groups of atoms. Okay? So the number doesn't change, just like 12 is a dozen whether you're buying eggs or donuts. Right? And so, just as a reminder, what kinds of questions did we ask? We'll ask questions like this. How many atoms of carbon are there in 4.56 moles of carbon? Look familiar? Okay. And remember, we write down what they gave us. Turn off the touch screen. Yeah, I'll get it in a second. Turn off this because it makes a mess if I don't. Okay, so 4.56 moles of carbon. The unit I wanted to get rid of was moles of carbon. Get that homework from behind you. Something behind you now. Oops. Need to say homework. Today, workday home. Okay. So you should have most of this done already, right? Because what has to go? What do we want to get rid of? Moles of carbon. Where's it got to go? On the bottom. What can I turn moles of carbon into? Atoms, because carbon's an element, its smallest piece is an atom. And 1 mole is 6.022 times 10 to the 23rd atoms. Familiar? Okay. Like I say, on the final exam, this number was where people struggled because they didn't have that number down. All right. And I get, 4.56 has 3 sig figs. 6.022 is 4 sig figs. So my answer can only have 3, which is 2.75 times 10 to the 24th atoms. Extra super tough? Oh, good to have lots of time to practice. Okay. And then we added atomic mass to it. The mass of 1 mole of an element in grams. Anybody remember how the heck we figured out the atomic mass of something? We calculate the average, but if we just want to know, if I want to know what the average atomic mass of, or what the atomic mass of carbon is, what do? I look at the periodic table, look for the decimal number, right? So 12.01 grams of carbon, 1.01 grams of hydrogen, 55.85 grams of iron. Those all have exactly the same number of pieces. That decimal number on the periodic table, right? So the decimal number on the periodic table is how many grams for 1 mole. So that we have something else we can turn moles into. Just doing a quick review of where we left this stuff off last semester. It's coming back. Surprise, surprise. And that let us answer simple questions like this. How many moles is 4.61 grams of magnesium? It may seem like I went through those last 2 slides real fast. That's because I've shown them to you before. You've already got those notes. I was just trying to remind you of where we were at. So I write down what they gave me, and I want to change it into how many moles. So I look at the units. The unit I want to get rid of is grams of magnesium. It goes on the bottom. Change that into moles of magnesium. It goes on the top. And according to my periodic table, 1 mole is 24.31 grams. Set it up so the grams cancel out. And if I do that math, 4.61 divided by 24.31 equals, with 3 sig figs, 0.190 moles of magnesium. Okay? So I can figure out how many pieces with moles. I can figure out how heavy with moles. Or I can put them together and start off with how heavy it is and end up with how many pieces there are. How many atoms would there be in a gram of lithium? So I write down what they gave me. The unit I want to get rid of is grams of lithium. It has to go on the bottom. Grams of lithium I can turn into moles of lithium. Because 1 mole is 6.94 grams. I was right, but I doubted myself, I think. That tells me how many moles of lithium, but it doesn't tell me how many atoms. So I can take moles of lithium and turn them into atoms of lithium. It's 1 mole in Avogadro's number. Or that's Avogadro's number. And 1 divided by 6.94 times 6.022 EE23 equals 8.68 times 10 to the 22nd atoms. Ta-da! Okay, just a quick reminder of this is what we did with moles last time we did it. Right? So now, that was all about elements. Now we have to change it into compounds. Okay. So, where was it? Something got erased. Okay. So, Avogadro is going to be the same for everything. Avogadro's number, just like doesn't always means the same thing. Avogadro's number always means the same thing. But the weight of the compound, I need grams of the compound to moles of the compound. If I want to be able to figure out how many pieces there are by weighing them. So I want to be able to do that same math. Start off with a gram and end up with molecules, or end up with formula units, one of those two. So I need to be able to go from grams to moles in that first step. Right? And I know how to figure out moles, grams per moles for atoms. What do I do in a compound? Well, here's the whole idea behind it. Yeah. The divide's wrong. Yeah, almost everything up there was because I want to figure out how heavy it is. Well, here's the logic behind it. In a mole of water, there are 2 moles of hydrogen and 1 mole of oxygen. Does that make sense? Because in one water molecule, there'd be 2 hydrogen atoms and 1 oxygen atom. In a dozen water molecules, there would be 2 dozen hydrogens, 1 dozen oxygens. In a million water molecules, there would be 2 million hydrogens, 1 billion oxygens. And when I get to a really big number like Avogadro's number, in Avogadro's number of waters, there's going to be 2 times Avogadro's number of hydrogens and 1 times Avogadro's number of oxygens, which is easier to say as in 1 mole of water, there's 2 moles of hydrogen and 1 mole of oxygen. Are we okay with that? So now we can do what Peter said. Find the mass of 1 mole of a compound, determine how many moles of each element they have. That's really easy. It's a subscript. Or maybe a subscript in parentheses. Ooh, we haven't done that one yet. Find out how much they would weigh. That means look them up on the periodic table. Add, because mass is conserved. Yeah, going with the complicated way of, the way to figure out how heavy it is to figure out how heavy all the pieces are and add them together. That's how they weigh airplanes. I mean, a 747 weighs 500, 600,000 pounds. Do you think they drive it on a scale? No, they add up how heavy all the pieces are. Okay. So what is the mass of 1 mole of methane? Yeah, well, I look up carbon on the periodic table. It's 12.01 grams. I look up hydrogen on the periodic table. It's 1.01 grams, but how much hydrogen do I have? I got 4 moles, right? So 4 moles of hydrogen times 1.01 gram for each one is 4.04. So 1 mole of CH4 is going to weigh 16.05 grams. Incredibly tough? Nah, it's not that. It makes perfect sense, right? You just add them up. So let's do a couple more because they are really that straightforward. You look up the numbers on the periodic table, you add them up, and what you're figuring out is 16.05 grams of CH4 equals 1 mole of CH4. That's our conversion factor. Because the thing at the beginning, the 1 mole, equals the thing at the end, 16.05 grams. The equal signs mean, right? So let's try dinitrogen tetroxide. Ooh, I can say the names out loud. It's halfway through the year, I finally get to talk chemistry. So what do I have to worry about here? If I got N2O4, well, I've got 2 N's, 2 moles of N, and 4 moles of O. I look on the periodic table, and each N is 14.01 grams per mole. So that's 28.02 grams. Look up oxygen on the periodic table, it's 16.00 grams. That's 64.00 grams. 2029, 92.02 grams. Ta-da. And that's what I expect the math to look like. Let's talk about sig figs. Okay. The first numbers are counted. Whole numbers, unlimited sig figs. When you look the number up on the periodic table, I always want 2 decimal places. Okay. Yours rounds it off to 2 decimal places automatically. Okay. Because we don't get that much information by carrying on all those extra sig figs. Okay. Over here, you say, what if this had been 8 O's? And I multiplied it by 16. My calculator would give me 128. And I'd be tempted to put 0.0. But actually, I'm not multiplying by 2. I'm not multiplying by 8. I'm adding 8 times. Does that make sense? I'm trying to save myself time, but I'm adding 8 times. So I want to keep, since I'm adding, I want to keep decimal places. So every one of your molar masses should have 2 decimal places. Because we're really adding up 8 carbons. Does that make sense? Okay, and then let me make it as nasty as I can make it. What's the molar mass of calcium nitrate? Yeah, I can do that. Well, that's the mass of calcium nitrate. What's the mass of 1 mole of calcium nitrate? Well, what do I have to worry about? 1 calcium. Here's the tricky part. How many nitrogens? 2 nitrogens. And how many oxygens? 6. Because really what I'm doing is Ca, do it over here. Ca, NO3, NO3. Right? Ca2 plus, NO3 minus minus. So that is 2 N's and 6 O's. Right with that? Some people want to add them, some people want to do other things with them, but really it's NO3 means NO3 and NO3, that's 2 N's, 6 O's. So calcium on the periodic table is 40.08 grams. So that's 40.08 grams of carbon. Oops, forgot to put the 8 in here. The nitrogen's 14.01 grams. So that's 28.02 grams of nitrogen. And the oxygen is 16.00 grams. And 6 times 16 is 96.00 grams. Oxygen. And if I add those up, 0, carry the 1, 14, carry the 1, 16, I get 164.10 grams. Yeah, 64.10 grams. Reasonable? The tricky thing is counting the oxygens on that one. Okay? But otherwise, it's the same process. So that says that 1 mole of calcium nitrate weighs 164.00 grams. Okay. That's my conversion factor. We're going to have to make our own conversion factors. Instead of just looking them up like we've done in the past, this one we have to create our own. Okay? But it's not too hard. Some adding. So, there we go. How many moles is 5.69 grams of sodium hydroxide? This sounds a lot like the first question we answered today. How many between moles and grams? Okay. So I'm going to start off that way. I'm going to write my 5.69 grams, and you want to include the chemical. I want to put NaOH there. Why do I want to put that NaOH there? Well, because eventually that's what we're going to change with a conversion factor. We're going to change chemicals. So you want to keep track of what chemical we're talking about along the way, because eventually we're going to change chemicals in the middle of our math. So we want to keep track of it along the way. What unit do I want to get rid of? Grams of NaOH. Where's it got to go? On the bottom. What can I turn grams of NaOH into? Well, I'd like to be able to turn grams of NaOH into moles of NaOH. But I would have to know how they equal each other. Oh, I'd have to figure out how heavy 1 mole of NaOH is. So I look them up. Sodium is 22.99 grams. Oxygen is 16.00 grams. Hydrogen is 1.01 grams. 1.01 and 22.99 is 24. 24 and 16 is 40. So 1 mole of NaOH weighs 40.00 grams. When I was in high school, we had to accidentally memorize this. Well, because we took tests without calculators. And 40 is pretty easy to do math with in your head. So sodium hydroxide showed up on our test all the time. Because they had to take there was a world before calculators where every calculation had to be hand done. Okay. So, see that this down here is just what we did a second ago, right? Just so happens there's only one of everything, so I didn't have to do any multiplication. And I did all that so I could take those numbers and stick them up top. I can now say that 1 mole of NaOH is 40.00 grams of NaOH. So see what I mean? Build your own conversion factor. And I push those buttons and I get 0.142 moles of NaOH. The reason why we want to be able to count the pieces is if you think about a chemical reaction, chemical reactions happen pieces at a time. So by counting the pieces, I'll be able to figure out how much I make in a chemical reaction. If I know how many pieces I put in, I'll be able to figure out how many pieces I get out. Except we don't want to count individuals, we're going to count big groups of them. Okay? That's the strategy. That's why we're keeping the chemical, because we're going to change it along the way, and that's why we're counting the pieces. It's because that's how chemistry happens, one piece at a time. Let's try some examples. How many molecules is 9.87 grams of CH4? So I started off a weight, grams of CH4. I want a number. I want a number of pieces, molecules. I don't have grams and molecules, but I can connect both of them to moles. So moles is my method of connecting the two. So the unit I want to get rid of is grams of CH4. I still put that chemical because soon we're changing that. And I can change that to moles of CH4. Now, luckily for us, we've already done this math. It was our example, the first molar mass example we did was CH4, right? And we found it was 16.05 grams. Everybody okay with where I got that 16.05 from? It was like 6 slides ago. Okay. And it gets rid of my grams of CH4. Now I want to get rid of moles of CH4 and turn it into molecules. Why is it molecules? Because they're both nonmetals, right? Because we got three types of pieces. We've counted atoms before. Now we're counting molecules, and next we're going to count formula units. Because this is molecular, because this is something you'd put a prefix on. It's a molecule. The things you put prefixes on are molecules. And 1 mole is how many molecules? Avogadro's number. 6.022 times 10 to the 23rd. So I take on 9.87 divided by 16.05 times 6.022 EE 23 equals. Start off with 3 sig figs in the 9.7, 4 in the 16.05, 4 in the 6.022, so I only have 3 in my answer. So that is 3.70, got to keep the 0, times 10 to the 23rd molecules of CH4. I could work that backwards. If I started with molecules, you could turn to grams. Right? If we can do it one way, we can do it the other. If I had 6.8 times 10 to the 24th formula units of K2S, K2S is going to be formula units because K is a metal. So this is ionic. It's ionic, the piece is a formula unit. I think I've said that like 5 or 6 times this year because it's the hardest one to fight because somebody taught you molecule once and you never want to move away from it. So 6.8 times 10 to the 24th formula units, K2S. What unit do I want to get rid of? Formula units. Where's it got to go? On the bottom. What can I turn formula units of K2S into? Well, formula units a piece. So I can turn pieces into bunches of pieces, right? Moles, K2S. Formula unit is just like a molecule, except it's for ionic compounds. We use it just like a molecule. And 1 mole of K2S is going to be Avogadro's number of formula units. Avogadro's number of pieces, in this case, the piece is a formula unit. Then I'd be able to turn moles of K2S into grams of K2S as long as I do some math. I've got 2 Ks and 1 S. Look up K on the periodic table, it's 39.10 grams, so that's 78.20 grams of K. The sulfur on the periodic table is 32.0, what does it say on yours? Because just say 7? Okay, 32.07. Depends on periodic tables whether they put a 6 or a 7 there. It's right at the border of rounding for that next sig fig. So that is 32.07 grams. So I add those together, 7, 2, 10, carry the 1, 110.27 grams of K2S. So that means 1 mole of K2S weighs 110.27 grams. Build your own conversion factor. That equals 6.8 EE24 divided by 6.022 EE23 times 110.27. I ignore all the ones because there's no sense multiplying or dividing by 1. And when you're done with this, calculator screen fills up with numbers. You got to decide where to round. The 6.8 times 10 to the 24th has 2 sig figs. The 6.022 is 4, and the 110.27 is 5. So my answer should have 2. So that is 1,200, because I got 1245 on my calculator, grams K2S.